For more than 70 years, humanity believed it fully understood the solar system. A neat and familiar picture. 9 planets orbiting the Sun, no more, no less.
But in the farthest reaches, within the dark, frozen realm far beyond Pluto's orbit, a silent shadow exists.
It was nothing more than a faint point of light, drifting so slowly it was almost impossible to notice. Hiding within old astronomical images, overlooked and forgotten for many years. When it was finally discovered, it was not merely the 10th planet. Its appearance shook the very foundations of astronomy. It forced the scientific community to confront a question that seemed simple, yet painfully profound. What truly qualifies as a planet?
This is the story of Eris, a world true to its name. Sowing discord and forever rewriting the map of the solar system.
The story did not begin with a chance moment at a telescope, but with a large-scale survey campaign on the outer edge of the solar system.
At Palomar Observatory in California, 3 astronomers, Mike Brown, Chad Trelegeau, and David Rabinowitz, were quietly scanning the distant sky, hunting for celestial bodies beyond Neptune's orbit, known as trans-Neptunian objects.
They used the Samuel Ocean Telescope with its 1.2-meter mirror, combined with automated software to detect points of light moving at an extremely slow pace. Through this method, a series of new icy worlds such as Quaoar, Orcus, and Sedna gradually came into view. But Brown believed that something even larger was still waiting to be found. And when it was confirmed, every old definition would collapse.
He once wrote, "The idea that Pluto was a unique misfit at the edge of the solar system seemed absurd to me. There had to be another planet out there." And then, on January 5th, 2005, while manually re-examining old data, Brown paused at 3 images taken in October 2003, where a faint point of light was slowly shifting against a background of motionless stars.
One glance was enough. He immediately knew this was no ordinary object.
It was too bright to be a small object, and too slow to be nearby, which could only mean one thing: it was enormous and incredibly distant.
In that moment, Brown's first thought burst forth. I've just discovered a planet. The object, temporarily designated 2003 UB313, was quickly subjected to closer observation.
But science is not always patient. When another team unexpectedly announced the discovery of a large TNO based on Brown's publicly available data, he was forced to make an early announcement.
On July 29, 2005, the world learned of the existence of Eris. And from that moment on, the old order of the solar system collapsed.
In Greek mythology, Eris is the goddess of strife, the one who hurled the golden apple inscribed "For the fairest" into a wedding feast, igniting the chain of events that led to the Trojan War. And in modern science, Eris did much the same.
Measurements showed that Eris was larger than Pluto. And when the orbit of its moon Dysnomia was calculated, its mass was confirmed to be about 27% greater than Pluto's. This made an unavoidable question emerge. If Pluto is a planet, then what is Eris? And if Eris is a planet, how many more planets are still waiting to be recognized?
From Makemake, Sedna, to many other large objects on the fringes of the solar system, where exactly was the boundary? Who was allowed into the Planet Club and who was not? This discovery pushed astronomy into an unavoidable logical crisis. As Mike Brown bluntly put it, either we had to add new planets or we would be forced to take one away. Under this pressure, the International Astronomical Union could no longer avoid the issue. In August 2006, at its 26th General Assembly in Prague, for the first time in history, this seemingly obvious question was formally debated and put to a vote. What is a planet?
The debate quickly grew heated, splitting the astronomical community into two opposing camps, each defending a completely different interpretation of what truly defines a planet.
The first camp supported a geophysical definition. According to them, a planet should be defined by its intrinsic nature. If an object has enough mass for its own gravity to shape it into a nearly round form, reaching hydrostatic equilibrium, then it deserves to be called a planet. By this definition, Pluto, Eris, and dozens of other icy worlds would all be promoted at once.
The other camp emphasized a dynamical criterion. They argued that a planet is not merely a round sphere, but the dominant ruler of its own orbit. A true planet must clear its orbital neighborhood and become the gravitational force that controls all surrounding objects.
The voting process itself was deeply controversial. The final vote took place on the last day of the 10-day conference, when most of the more than 2,500 scientists had already left, leaving just 424 people to raise their hands and decide the fate of the solar system.
The result was that the dynamical definition prevailed. The International Astronomical Union adopted Resolution 5A, establishing a three-part definition for a planet in the solar system. It must orbit the Sun, have a nearly round shape due to its own gravity, and have cleared the neighborhood of its orbit.
Pluto, by sharing its orbital space with Neptune and countless objects in the Kuiper Belt, failed to meet the third criterion. A new term was born, dwarf planet. Reserved for celestial bodies that meet the first two conditions but fail the final one. More importantly, a follow-up proposal to classify dwarf planets as a subcategory of planets was rejected. Instead, the International Astronomical Union declared that planets and dwarf planets are two entirely separate categories.
In a single moment, the solar system was officially reduced to 8 planets.
Of course, the decision was immediately met with criticism. The phrase "clearing the neighborhood" was seen as vague and difficult to quantify, while the criterion "orbiting the Sun" applied only to our own solar system, ignoring the thousands of exoplanets already discovered. As a result, this definition was viewed not as a universal and elegant concept, but as a patchwork solution born out of crisis.
Nevertheless, once everything was settled, the Discovery team was finally granted the right to name their troublemaker. They chose Eris, the goddess of discord in Greek mythology, a perfect symbol for the celestial body that had thrown an apple of disagreement into the heart of the scientific community. The name was officially recognized in September 2006.
If Pluto could think, it surely wouldn't be happy about losing its planetary status. But that change also created new winners, such as Eris. Once considered merely an asteroid, now stepping onto the stage as a dwarf planet.
After establishing its place as a cosmic disruptor, it is now time for us to go deeper, to confront Eris directly and uncover the true nature of this rebellious world.
Eris does not reside in the relatively stable Kuiper Belt, where Pluto and many other icy bodies live. Instead, it belongs to a far more distant and chaotic realm, known as the scattered disk, an exile zone of the solar system. This region is home to icy objects with extreme orbits, believed to have formed closer to the Sun before being flung outward by Neptune as the giant planet migrated billions of years ago.
Eris's orbit is far from circular. It follows a vast elliptical path that takes 557 Earth years to complete a single revolution. At perihelion, Eris approaches to about 38 astronomical units, roughly comparable to Pluto's average distance. but at aphelion, it swings out to nearly 98 astronomical units, about 15 billion kilometers, almost 3 times Pluto's current distance from the Sun.
It doesn't stop there. Eris's orbit is tilted by as much as 44 degrees relative to the ecliptic, the plane along which the major planets travel. As a result, over the course of its 557-year-long year, Eris repeatedly soars far above and then plunges deep below the rest of the solar system, like a wanderer that never truly belongs. For many years, Eris was considered Pluto's giant twin. But it was not until 2010 that astronomers finally had the opportunity to measure it with unprecedented precision, thanks to a rare and fleeting event.
Eris happened to pass in front of a very distant star, creating a stellar occultation. By measuring how long the star's light was blocked from different locations across Earth, scientists were able to determine Eris's size with near absolute precision.
The result surprised everyone. With a diameter of 2,326 kilometers, Eris is almost the same size as Pluto, even slightly smaller. But the crucial difference does not lie in size. Eris has a mass up to 27% greater than Pluto, compressed into a smaller volume, resulting in a significantly higher density, about 2.43 grams per cubic centimeter, compared to Pluto's 1.85. This reveals a very different internal structure, one dominated by a rocky core wrapped in only a thin layer of ice, a stone heart encased in a frozen shell.
That outer shell is also one of the brightest surfaces in the solar system, with an albedo close to 0.99, meaning it reflects up to 99% of the sunlight that strikes it. An extraordinarily rare level of brightness.
This brightness may come from a process known as atmospheric collapse. Like Pluto, Eris has a thin atmosphere composed mainly of nitrogen and methane. But when Eris drifts out to its deep, icy aphelion, that atmosphere freezes and falls onto the surface as fresh white frost, cloaking Eris in a shimmering layer of ice, like newly fallen snow.
As Eris begins its 280-year journey back toward the Sun, that frost slowly warms and sublimates, turning from ice into gas and giving rise once more to a fragile atmosphere. Then, centuries later, as Eris drifts again into the deep frozen darkness, the atmosphere freezes solid and falls like snow once more. A slow, rhythmic breathing that unfolds over hundreds of years.
More recently, observations from the James Webb Space Telescope have made the story even more complex. Analyses of methane isotopes on the surface of Eris suggest that they may have been produced by geothermal activity, hinting that deep beneath its icy shell, Eris's rocky core could still be warm, or at least may have been warm in the distant past.
An icy world, yet one that may conceal an unexpected warm heart within.
The decisive piece to decoding Eris and the final evidence that sealed Pluto's fate emerged in September 2005. When using the Advanced Adaptive Optics System of the W.M. Keck Observatory, Mike Brown and his colleagues detected a faint point of light orbiting Eris.
Eris has a moon named Dysnomia.
This detail changed everything. The size of a celestial body can be estimated from its brightness, but its mass can only be measured precisely by observing its gravitational pull on another object. By tracking the nearly circular 16-day orbit of Dysnomia and applying Kepler's laws, the research team was able to calculate the mass of Eris with remarkable accuracy.
The result was decisive. Eris is more massive than Pluto. And from that moment on, the debate over what constitutes a planet was no longer theoretical, but an urgent issue that forced the scientific community to define the term clearly.
That moon itself is also remarkable. Although its diameter is only about 25% that of Eris, it remains one of the largest moons ever discovered orbiting a dwarf planet, second only to Pluto's satellite. And it is even larger than Enceladus or Mimas, the moons of Saturn.
It is tidally locked to Eris. Yet estimates suggest its mass is too small to produce this effect through the usual mechanisms. This implies that Eris dissipates energy more efficiently than scientists had previously believed. If Eris is blindingly white, then its moon is pitch black. Dysnomia has been described as darker than coal, indicating a surface poor in bright ices, starkly contrasting with the reflective frost that blankets Eris.
The most widely accepted hypothesis is a giant impact in the early solar system, similar to the event that formed Moon. In this scenario, the collision blasted material into orbit, which later coalesced into a moon, while stripping away volatile ices and leaving behind a dark, rock-rich body.
True to mythological tradition, if Eris bears the name of the goddess of discord, then its moon was named Dysnomia. The daughter of Eris, the embodiment of lawlessness and chaos. A perfect name for a satellite born of violence, orbiting the world that overturned the old order of the solar system. After the 2006 vote, Mike Brown was often saddled with an unflattering nickname, the Killer of Pluto.
But his true legacy is entirely different. Eris did not kill Pluto, it helped Pluto find its family. And thanks to Eris, the solar system is revealed to be far larger, more complex, and far more fascinating than we ever imagined. Instead of a distorted model with 8 standard planets and a single outcast, we now have a more coherent picture. 4 inner rocky planets, 4 giant gas and ice planets, and beyond them a third realm, where thousands of icy dwarf planets roam in the darkness, with Eris and Pluto standing as its most prominent kings.
Yet Eris remains an ultimate enigma. It is the most massive object in the solar system that has never been visited by a spacecraft.
While the New Horizons mission delivered a breathtaking close-up portrait of Pluto, Eris remains nothing more than a distant point of light. guarding its secrets across billions of kilometers of empty space.
A flyby mission to Eris, if ever approved, would take around 25 years to reach its destination. A journey stretching across generations.
In the near future, the goddess of discord will continue to whisper from afar. She has closed one great debate, yet at the same time opened a new chapter in humanity's journey to explore the cosmos, with Eris standing silently at its threshold.
The greatest discoveries are not final answers, but reminders of how much still remains unexplored.
And so, from a tiny point of light at the edge of the solar system, Eris achieved something few worlds ever could. It made all of humanity argue all over again from the very beginning. Not because it is the largest, not because it is the most beautiful, but because it asks the most uncomfortable question of all. What, in the end, truly defines a planet?
Pluto lost its title. Eris never needed a crown. And we were left realizing a rather amusing truth. The universe doesn't care what we choose to call it at all.
It keeps on orbiting. Still cold, still distant, and still filled with secrets no one has yet touched.
Perhaps somewhere out there, beyond Eris, another troublemaker is waiting to be discovered, ready to throw yet another apple into our map of the universe.
And next time, we may have to rewrite the textbooks once again.
And for now, if the solar system feels a little wider, a little stranger, and a little more fascinating to you, then Eris has already fulfilled its role. Thank you for wandering with me all the way to the edge of the planets. Until our next journey, where the universe will always have something new to surprise us.